This is part 3 of section 4.1. We want to convert each of these angles from degrees to radians, and we want to round to 2 decimal places. First of all, if it's positive in degrees, it's positive in radians. If it's negative in degrees, it's negative in radians. So we just have to keep the sign. That's not really that much of an issue. If we have degrees and we want to go to radians, we're going to multiply this value by pi over 180. Okay, so this gives me 127 pi over 180, and that is the exact answer. But we're asked for an approximation to 2 decimal places. When you do these approximations, you need to make sure that you are using the pi button on your calculator, because the pi button holds more decimal places than you would ever want to write down yourself, and you'll get the more exact answer. Okay, so if I do 127 pi divided by 180, I get approximately 2.22. 2.22 radians. Now, often in math, if you don't see the degree symbol, you understand that it is in radians. In the beginning, your book will use 2.22R to indicate radians. Again, we normally drop that. Now, that said, if your angle is in degrees, you would better make sure that you include this degree symbol. Otherwise, all of your math is going to be wrong. Everything is wrong. Okay, so let's convert negative 175 degrees into radians. So again, I'm going to multiply by pi over 180. That gives me negative 175 pi over 180. Now, if you are asked for an exact answer, they would expect you to reduce this fraction. And it reduces to negative 35 pi over 36. And let's get an approximation of this. It's going to be negative 35 pi divided by 36. And I get approximately negative 3.05. Okay. Now we're going to convert radians into degrees. And all we do is reverse what we multiply by. So when I was converting from degrees to radians, I multiplied by pi over 180. Here, I'm going to multiply by 180 over pi. Okay, so 5 times 180. And then divide by pi, gives me approximately 286 rounding to 2 decimal places, 286.48 degrees. Don't forget your degree symbol. Okay. Negative 6.28 radians to degrees. Now, if you aren't careful, you will mess this up, because we normally, if we just use an approximation for pi, we use 3.14. And this is 2 times that. But we're supposed to use the pi button, not the approximation. So I'm going to multiply this by 180 over pi. So negative 6.28 times 180. And then divide by pi, we get negative 359.82 degrees. Notice how close that is to 360? And it should be, because this was an approximation, and negative 2 pi would be negative 360 degrees. Okay, now here are the relationship between some very common positive and negative angles. You really, really, really want to memorize these. And I'm speaking from experience. I did not, and I struggled through calculus because of that. In fact, everything in this trig unit that I ask you to memorize, it is because I know what happened when I didn't memorize them. Okay? Now, we already know about coterminal angles. So if we go around and then around and around again, okay, we can keep making circles as many times as we want to and end up at a particular line. So right here, if this is 30, I can rotate around 360, and I'm back here, another 360, another 360, okay? And we summarize that in this. An angle theta has infinitely many coterminal angles, okay? If our angle is measured in radians, then we can add any multiple of 2 pi. 2 pi is all the way around. So I could add 2 pi, I could add 4 pi, I could add 10 pi. I could also, n can be a negative number, n is an integer. So I could add negative 2 pi and end up with a coterminal angle. And the same thing happens here, except instead of 2 pi being all the way around, if we're measured in degrees, we can add any integer multiple of 360 degrees and come up with coterminal angles.